In this video, we will continue practicing graphing secant, cosecant, and cotangent functions with all kinds of changes in phase shift and vertical shift and a value. Alright, first of all, I would really like to rewrite this equation. Whenever I see a b value like this and a potential phase shift, I really need to factor that b value outside of parentheses. So let's get that done right now. So I need to take that 1/2, bring it outside parentheses. Okay, and when that happens, if I want to know what goes here, I need to divide this number by the b value. So if I've got essentially 5 pi over 12, and I need to divide that by 1/2. Alright, I'm doing this divided by this. I need to multiply by the reciprocal. So this would be 5 pi over 12 times 2. Well, isn't that 10 pi over 12? Whoa! Isn't that 10 pi over 12? And doesn't that reduce to 5 pi over 6? So that's what needs to go here. Minus 5 pi over 6. So that's going to be my phase shift. But let me just finish writing this. So I've got parentheses inside of parentheses. This is the secant function. I've got this a value of 3. And I've got this vertical shift of -2. So this is going to be quite a function to graph. This should be interesting. Let me just clean this up a little bit. Alright, looking at the parts of this, the 3, there's no negative in front of it, so there is no reflection, which is one of the things that we're being asked. So reflection, no. The period. The period is always the normal period divided by the b value. When it comes to secant, we know that secant is the reciprocal of the cosine function, and both cosine and secant have a period of 2 pi. So I'm going to do 2 pi divided by the b value. That means the period is going to be 2 pi divided by 1/2. Which means that the period is going to be 2 pi times 2, so the period is 4 pi. Okay, so the period is 4 pi. Great. Phase shift. This is the phase shift right here, except for the negative sign. The phase shift will be positive 5 pi over 6, and let's go ahead and say that it is to the right. There is a vertical shift. It is -2 or down 2. Okay, we will talk about the vertical asymptotes after we have done the graph. Okay, because secant is the reciprocal of the cosine function, the first thing I'm going to do is I'm going to graph my cosine function very gently and lightly, but nevertheless, I'm going to graph this cosine function. Let's see, this is down 2, so I'm going to move this line a little bit because I need to leave myself space in which to do that. And it's shifted to the right. Okay, so we'll see what happens. But anytime I have a phase shift happening, what I really like to do is start at the phase shift. That's my favorite thing to do in the world. Okay, so since I have a phase shift at 5 pi over 6, then guess what? I'm going to start at 5 pi over 6. Okay, I'll just put it right about here. Leave myself some space over there. So 5 pi over 6. Now, I'm going to go over 4 positions to the right. 1, 2, 3, 4. Okay, every one of these positions will be 1/4 of the period. So by the time I move 4 places, this should be the end of the period. This is where the period ends. However, I need to know what these numbers are. I got to label this stuff. So what am I going to do? Whenever I have a phase shift, I like to do this little thing with the fact that each one of these positions is 1/4 of the period. So I like to calculate what is 1/4 of the period. What is a quarter period? Well, let's see. The period is 4 pi. So a quarter of the period is just going to be pi. So pi is a quarter period. So that means if I want to get from 5 pi over 6, where I'm starting, to the next value, I should be able to simply add pi to that. However, I need like denominators in order to add these. So, like denominators, I would just multiply the numerator and denominator by 6, right? Because pi is the same thing as 6 pi over 6. That's what's happening right here. So fine, now I have like denominators. Okay, so I've got 5 pi over 6. You know, I don't know why I'm just recopying this down here so it'll be in line with my other stuff, but I just recopied it. So I have this 5 pi over 6, and I'm going to add 6 pi over 6 because I'm going to the right. 5 plus 6 is 11, so that makes this next position would be 11 pi over 6. Alright, the next position over should be another 6 pi over 6 to the right. See, I'm just adding pi every time, but I'm just using like denominators. So if I add another 6, then this would be 17 pi over 6. If I add another 6, that's going to be 23 pi over 6. If I add another 6, that's going to be 29 pi over 6. Wow, do any of these reduce? No. Well, now I feel silly for putting them. I usually put the numbers down here because usually some of them reduce, and then I put those values up here. But nothing actually reduced, so I feel stupid. So I'm just going to recopy them now. Just don't pay attention to this. So I have 11 pi over 6, 17 pi over 6, 23 pi over 6, and 29 pi over 6. Great. Now I have to erase this. Well, maybe I won't erase it yet. I need, these are the values that I'm going to need, these 5 values right here. However, I do need to know where my y value, where my y-axis is. So I'm going to put some additional values going off to the left until I find where the y-axis goes. I'm going to put these in a different color because these are the ones that matter. So I think I'll just switch from gray to black. So hopefully I'm going to hit the y-axis pretty soon because I don't have a ton of space as I'm going to the left. So I was adding, I shouldn't have erased that so fast, but I was adding pi, right? Because that was a quarter period, and we had decided that that was 6 pi over 6, so I was adding 6 every time. Going to the left, I would be subtracting 6 pi over 6 because I'm decreasing. So, oh look, as soon as I do 5 minus 6, that's -1, isn't it? So that's going to be -1 pi over 6, or negative pi over 6. And that's what I was waiting to see, a negative, because now I know where my y-axis is. The y-axis is going to be somewhere between a negative x value and a positive y value. So now I know that I can draw my y-axis right in here. And that's what I will do, my friends. Okay, so I'm just going to put my y-axis right here. Okay, you cannot put your y-axis at the phase shift unless it happens to be 0. All right, that doesn't work. That's not okay. So remember, these gray numbers over here, though, these are the that's the cosine values that I'm going to use, the x values I'm going to use. Now, the reason why I need my y-axis in here, though, is because I need somewhere to mark my vertical shift and my amplitude for the cosine function. So first of all, let's get this vertical situation happening. Let's see, what color should I use? Green? Alright, sure, why not? Okay, so my vertical shift, alright, I'm going down by 2. Okay, and then I have an amplitude of 3, so that's like a total of 5, so I need to leave myself space. So 1, 2, 3, 4, 5. Okay, so this is -1, -2, -3, -4, and -5. Let's see, I'm thinking ahead. I'm also going to need a +1 up here, and you'll see why in a second. So because of the -2, my midline is not going to be the x-axis anymore. My midline is going to be down here at -2. So that's why I'm going to put a dotted line down here at -2. Okay, now I'm going to put an extra couple of lines in yellow. I know it's going to be hard to see, but I don't really want this to stand out very much anyway. What I'm doing is I'm indicating my amplitude. Counting from the midline, an amplitude of 3 means I should be going up 3 from the midline and down 3 from the midline. So looking at this -2, if I go up 3, I'm going to be at +1. That's why I needed +1 to definitely be marked, okay, on the y-axis. That's why I did that. I was thinking ahead, okay, using my brain. But I'm doing it in yellow because this is, optional. And then I'm going to go down 3 from the midline. So -2, if I go down 3, that would be 1, 2, 3. That's why I put this down here at -5. Alright, and I'm going to put this hard to see yellow line down here, okay, for my amplitude situation. Okay, great. Now I'm ready to start doing my cosine graph. Remember these 5 gray values? Not the y-axis, alright? That came later. These 5 gray values right here, these are the values I'm going to be looking at as I do my cosine. So when I do my cosine, which I'm doing cosine because secant is the reciprocal of cosine, you know how cosine starts out high? That's what I need this yellow line for. Cosine is going to start out at my phase shift. Remember, this was my starting value. And it starts out at the high point, where the A value is, the amplitude. And then this next mark over, it should be down to the midline. And the next mark over, it should be down to the low value, the negative A value. And then the next mark over, it should be back to the midline. And for the final mark, it should be at the high mark, above the midline, the amplitude above the midline. So this is my lovely cosine function. Now I'm not going to draw in a dark cosine function. I'm just going to very lightly sketch it. Alright, just as lightly as I can in a very dotted type nature. Okay, just very delicate, very dainty. Alright, because this is not the real graph, so I don't want it to get too much attention. But I need it in order to draw the real graph, which is secant. Okay, now, man, I hope I left myself enough room. Because secant is 1 over the cosine, then if cosine is 0, that's where I'm going to have an asymptote. And I'm seeing, now I know that this doesn't look like it's 0, but that's just because of the vertical shift. If it weren't for the vertical shift, this would have been at 0. So these are still the points I'm going to look at for my asymptotes. So these are the points that where the cosine function would have been 0 if it hadn't been for all this shifting business. So this still tells me where the asymptotes are. So right here, just pretend, imagine that this midline is the x-axis. Then you would think of these two positions as the x-intercepts if it had been the x-axis. Okay, I mean, it gets a little weird with the shifting, but the vertical asymptotes will be right here at these 2 points of the cosine function. Okay, they've just been shifted a bit. Okay, so I'm going to make my dotted lines right here and here at 23 pi over 6 as well. Okay, and I have learned that this high point of the cosine function is also going to be part of the secant function. So I'm going to start here and I'm going to go towards the asymptote, but away from the midline. Same with this point over here. That's going to be on the secant function, and I'm going to approach the asymptote going away from the midline. And we have learned that this point down here on the bottom is going to be part of the secant function. And on the left and the right, I'm going to approach the asymptotes like this. And there it is, ladies and gentlemen. That is what 1 period of the secant function right here is going to look like. Alright, now we can go ahead and talk about the vertical asymptotes. Notice there are no x-intercepts if you were asked about that. But vertical asymptotes, I like to just pick the first positive vertical asymptote, which is at 11 pi over 6. And vertical asymptotes are always x equals something. Any vertical line is x equals. So x equals 11 pi over 6. And then I just need to add the repetition. So I'm going to get, this is an infinite function that repeats over and over and over again. But the next vertical asymptote I come to, do I have to travel an entire period to get to the next asymptote, or is it just half of a period? Well, from this asymptote to this asymptote, that's only half of a period. The full period would be all the way from 5 pi over 6 to 29 pi over 6. But I'm only going from 11 pi over 6 to 23 pi over 6. I'm only going 2 spaces instead of 4. Alright, this is half of a period. So wait a minute, what was the period again? Oh yeah, that's right. The period was 4 pi. So half of the period would be 2 pi. So that's why I'm going to add 2 pi, and I'm going to put an n on there as a multiplier to represent the infinitely many asymptotes that are coming. Every time I add another 2 pi, I'm hitting another asymptote. So n is an integer, and I must mention that. Integers can be positive or negative. So if n is -1, -2, -3, then that's taking me to the left every time hitting another asymptote. So that's going to do it for problem number 6. Alright, there's the graph, and we've got all this good information. Okay, this video is long enough, even though it was only one problem. I hope it was helpful, and The next video, maybe I can just give you a little preview. Next video is problem number 7, cotangent. So I'll see you on that video.